Okay, this is an Eclipse electrical panel, typical mid run. It's got the combination power supply here with the high voltage and low voltage DC in it. Over here is where your power cord comes in. Your black and white wires are your hot and your neutral, or often referred to as L1 and L2, and there's your ground wire. So your ground wire, if you follow it, it goes up in here, up through here, and comes out right here and goes into this ground block. And these ground blocks are all tied to this metal bar back here, and so this metal bar ties all these ground blocks together, so you can see multiple green wires. The hot wire and the neutral wire, they go through this breaker, which is on the side of the machine over here. Let's see if we can get a picture of that right here. See that breaker right there with the serial number plate? Okay, it goes up here, and you can take these covers off and you can follow it, and it goes up to the power switch on your machine, and then it comes back and goes into these gray blocks right here that say L1 and L2. So that means if I have AC power and I have my switch turned on, then if I put a probe on L1 and L2, I should be able to measure AC power, 120 volts in the US, 230 volts elsewhere. So if I take my meter here and I set it over to AC voltage right there, and let's see if I can do this so that you can see it at the same time I'm testing. Kind of get oriented here. I got a latch on the back I can maybe hook right there. Come on. Well, I'll just hold it. I'll use my chopsticks fingers. Okay. So if I put black on L1 and I put red on L2, come on. Let me get my fingers going. I should get 120 volts, plus or minus 10%. So that's what I've got, L1 and L2 there. All right. Now, if this power supply is working, I should have 48 volts. And if I look up here at these, they say 48 volts and 0 volts. DC. So if I turn my meter to DC, which is with the straight line, right? And I put black on 0 volts, and I put red on hot, I should get 48 volts plus or minus 10%. So there we go, 44 volts. Okay. So that means I have power for my motors, because my motors run off 48 volts. Now, if I look over here, this is where I try to keep all the high voltage over here, the AC voltage, and try to keep all the DC voltage, low voltage over here, so we don't get any magnetic interference. So this area right here, this is a big power distribution for low voltage, and the top one says 24 volts, and all these say 0 volts, and this bottom one says 5 volts. So if I take my meter, we'll get it in the screen in a minute, but if I take my probe and I put it on the 5 volts, any screw on there, and then I put my probe here on the 24 volt screw, it reads 24 volts. Awesome. Okay. If I go down to the 5 volts down here and I touch that, must not be touching something. There we go. 5 volts, a little over. Okay. If this is under 5 volts by any amount, that will be a problem for your machine, because some of you, the home switches are running off of 5 volts, and 5 volts is the bottom that they can handle. This machine has been upgraded with these relays, so the home switches are running on 24 volts, and the signal on the other side going to the computer is 5 volts. You can see that this has got lights on it. These drives, each one of these drives. And you can see like this signal says HV and this one says ground. So this is DC voltage. So if I put my black probe on the screw where the black wire goes, and I put my red probe on the screw where the red wire goes, get over there, I've got 44 volts, same as I had over here, because those are all tied together. Okay, so that's how you can check the voltage in your system to make sure you've got the right voltages where you're supposed to have them. Okay.